AI physics engines expose why budget consoles crush viral performance myths. Everyone online swears the cheapest gaming devices are doomed to throttle, overheat, and disappoint. But what if those claims are just lazy assumptions waiting to be shattered by real simulation data? Stick around, because in the next few minutes I'm going to show you exactly why the numbers tell a different story. Let's kick off the affordable gaming device debate. On one side, you have the viral hot takes claiming anything under $300 will melt after 10 minutes of play. On the other, the actual hardware quietly delivering frame rates and thermals that surprise even the skeptics. The problem is most people never run the physics. They just repeat the meme. That's where AI-driven thermal and fluid simulations change everything. These engines model airflow, silicon hotspots, and power draw at a level no YouTube teardown can match. When we feed budget console specs into the same tools used by AAA studios, the results flip the script. Heat doesn't spike the way the myths predict. Instead, clever power gating and chassis design keep things stable far longer than the comment sections claim. Open loop here. But the real surprise isn't just heat. It's how these simulations expose performance headroom nobody talks about. We'll get back to that in a second. Take the latest round of budget handheld claims. Viral videos show devices hitting 90 degrees in minutes. AI physics runs tell a different tale. With accurate material properties and realistic load cycles, peak temps stay in the mid-70s under sustained play. The difference comes down to how the models treat variable fan curves and dynamic voltage scaling. Details most critics skip. Suddenly, the budget device looks engineered, not cheap. Another myth that crumbles under simulation is the idea that affordable hardware can't maintain consistent frame pacing. When AI engines simulate both the GPU workload and the cooling stack together, we see steady delivery where people expected drops. The viral footage usually comes from poorly optimized titles or blocked vents, not inherent hardware limits. The physics doesn't lie once you give it the right inputs. Here's the part that stings the loudest. Some of the most expensive devices actually show worse thermal gradients in the same simulations because their bigger batteries and denser components trap heat. Budget designs win on simplicity and airflow. That flips the value conversation completely. Open loop. And if the thermals are this misunderstood, imagine what the AI models reveal about long-term silicon degradation. We'll circle back before the end. So the next time a headline screams that cheap gaming hardware is broken by design, ask what the physics engine